Hello, we're going to take a look at an example where we're using slope to solve some questions. At the beginning of our slide, we have all kinds of information about what is going on in this picture. So we have an underground aquifer that sits on an impermeable layer of limestone, and it's east of the city. It slopes downward in a straight line. So that straight line is really important because that we know that a straight line has constant slope. And so we're going to be able to use slope to solve. It says in order to map this, they started drilling some sample wells 2 miles east of the city. They have a well that is 220 feet deep, and so we see that right here. And then 3 miles, so one additional mile, which we see up here. We have another well, and this well is 270 feet deep. So the first thing it asks us to do is find the slope of this limestone layer, and we were told that this is approximately a straight line in this area, and so we know that slope, which we use m for, is often remembered as rise over run, and we know that the rise, what we're really talking about, is the change in the y value or the change in the vertical, and that the run is the change in the x value or the change in the horizontal. So when we look at this little piece in here between the two wells that we have on the picture, we can see that the change in the horizontal, the distance between the two wells, is 1 mile. And so as we go to find this slope, we have here 1 mile as the bottom of that fraction. And then we want to figure out the change in the depth, which is our vertical distance. So our second well is 270 feet. Our first one was 220 feet. And so we subtract them to find that it has changed by 50 feet. So my slope right up here is 50 feet per mile. So this is going to, in this case, downhill 50 feet per mile, deeper 50 feet every mile. So then it says, use the slope to predict the depth of the limestone layer 5 miles from the city. So when I look at that 5 miles from the city, I have to go back over here to my picture and figure out where I am. Here's 2 miles, an additional mile, so that's 3 miles. So if I would continue out here for 2 more miles, so this is 2 additional miles, and my location here is at 5 miles. Well, that 2 additional miles is important because that is how far I want to change in the horizontal. And so the horizontal is the bottom of the fraction, so this is a change of 2 miles. And what I want to figure out is how much does the vertical change, how much will the depth of the wells change in that same distance. So we know that slope remains constant, so they are changing at 50 feet per mile. Oh, my pen today is really difficult. And so if I solve this, I can cross multiply. So 50 times 2 is 100 equals the question mark. And so there is a change of 100 feet. Now, that's not the answer though, because they don't ask me just how much does it change, they actually ask me the depth. So I have to keep in mind when I'm solving this proportion, I am finding in this case the change in y, not the y value itself, but how much it changed. So at the 3 mile mark, which is where I moved from, there was a depth of 270. There from that point is a change of 100. And so we actually get an answer here of 370 feet. All right, so last question on this slide is use slope to calculate how far from the city you would be if you drilled a well 290 feet deep. So from the picture and what we see on the picture, 290 feet would probably be like here because it's just a little bit deeper than 270. So if I had to make an educated guess at this, I would guess that it's 3 point some miles from the city. So if I'd go up here, it's a little past the 3-mile mark, but not the whole way out here at 5. So when I use slope to solve this, I am always thinking about, well, how much have things changed? So from a depth of 270 to a depth of 290, we see a change of 20 feet in the depth. And that is a vertical change, so that's going to go on the top of our fraction. So we have a change of 20. And we want to know a distance with that. So we want to know a change in x that would be associated with that change in depth. We know slope is constant, so we can put the equals in there. And for this problem, we found the slope to be 50 over 1. So I go ahead and use my cross product to solve this. So solving that out, I get change in x times 50 is equal to 20. And this is times 50 here, which didn't write. So then I would divide by 50 on both sides. Those cancel. Divide by 50 over here. And I would get that my change in x is equal to 0.4. And again, this is not the answer because this is not the total distance. This is only the change. So that is this little section right in here. And prior to that, we were 3 miles from the city. So our total distance from the city would be 3.4. Wow. So that's my decimal. That's a number 4 miles. So when we're solving a problem, we always have to keep in mind that slope is the change in the y value divided by the change in the x value. We can use slope to solve any time that we have a straight line because slope is constant. And then we have to think about where did we change from. So we have not changed from 0 in any of these problems. So we calculated the amount of change and then had to add it on to where we were previously located.